Hi there. Today I'm going to give a short presentation about Golgi, what Golgi is and how it can help mobile application development. And I'm also going to give a demonstration of how to build one of our sample applications, which is the source code for which is up on GitHub, how to download it, how to integrate it with Golgi, how to register for Golgi, download the SDK, build the application, and get it running. So, what is Golgi? Golgi is a mobile cloud service for cross-platform transport and connectivity. What that means is that Golgi allows the developer to have all the code for the data they want to exchange, for the modeling of the data they want to exchange, and for the actual exchanges and interactions between their mobile applications and their server-side infrastructure, have all the code for all of that automatically created for them by the Golgi SDK, rather than writing it themselves. This frees the developer up to work on whatever core problem they're trying to solve, rather than re-implementing or writing a new implementation, yet another implementation of a kind of mobile RPC or remote procedure call mechanism. So there are three kind of high-level portions to how Golgi achieves this. Developer-defined data contract, intelligent delivery engine, and multi-layered security. The developer-defined data contract is kind of at the heart of the power of Golgi. This is a flat file based data contract. What we mean by that is it's a place where the types of data you want to exchange are defined and the actual interactions are defined. And out of this, we generate all the source code for the mobile applications, both iOS and Android, and the server-side applications, be that J2SE in Java or Node.js in JavaScript. And it eliminates the kind of the arguments that often erupt between teams working on kind of those different entities about the format of the data that's being sent across, what should or shouldn't be in it. This is a single point, a canonical store, if you will, of the types of data and the types of interactions, and that's why it's called a data contract. From this we generate, as I say, all the code for all the endpoints, giving type-safe APIs where possible, and allowing the developer to move on to their whatever core problem they're trying to solve. In addition, as time goes by, it gives the developer a flexibility for extending and adding new features to their kind of their communication needs, without jeopardizing what they've written so far. Often, what happens with developers is as they extend the framework that they end up writing by themselves, they break existing code, and that's a nightmare and terrible from a productivity point of view. Second portion is our intelligent delivery engine. This is our cloud-based infrastructure which orchestrates all of the interactions between the mobile devices and your server-side backend. This is key to the kind of the power of Golgi, as it is optimized to manage the challenging IP environment that mobile devices find themselves in. Well, what this means is we're able to let your app run without persistent connections, using ephemeral connections and leveraging push under the hood as far as the developer is concerned, to only have a connection open when it's needed. It also allows us to rebalance the relationship between the mobile devices and the server-side infrastructure. Often today, all interactions are initiated by the mobile device because the server lacks an easy way to establish connectivity with the mobile device. With the Golgi approach to things, that inequality is rebalanced, and any entity can initiate an interaction, and the intelligent delivery engine will do whatever is needed to get the connectivity in place to perform that interaction. This leads to just a kind of a broader horizon of capabilities in the toolbox for the developer to solve things in a much more flexible and efficient manner, leading to better overall app user experience. And the third part is our multi-layered security. We use SSL kind of from a point-to-point point of view, so all the interactions between the mobile devices or the server side, the developer's server-side infrastructure, and our infrastructure is all SSL encrypted, but we also provide plugins to allow the developer to implement full end-to-end trust no one encryption. We appreciate that in some instances, in all instances, developers can be in a kind of a sensitive environment, and because our cloud-based infrastructure has access to the data as it goes by, it can be best if, in many situations, for that to be completely opaque to us from a data point of view. This allows them to do that with complete transparency. The developer is able to use their own encryption technologies, whatever they wish, and as it transits our system, we have no access to it apart from just from a routing point of view, so we can get it from A to B. All of these features combine to give you a situation where any edge device, be it a mobile device, a server side, even a browser on a desktop, can initiate interactions with any other device as if they were kind of peers of each other. And they can do that in a type-safe and efficient fashion, and Golgi will manage all the interactions and all the network connectivity requirements in order to do that in a safe, reliable, robust, and extensible way. So now we move on to the kind of demonstration portion of things. I'm going to show you how to build and run and set up a demonstration application we built called EC2 Wingman. It's a mobile application, very handy for mobile developers if they've got any EC2 instances running in Amazon. It provides continuous monitoring of the instances, gives you a list view of all the instances based on CPU usage, and will send you kind of asynchronous alerts for things like CPU usage, status check failures, instant state changes, and just so that you can keep on top of things happening unbeknownst to you within your EC2 system. The technology involved on the server side, we've got Node.js, and on the mobile side, it's a native Android application, which I'll show here today. We also, in the source code, there's a native iOS application also, but today I'm going to just talk about and demonstrate the Android side of things. And all the source for this is publicly available on our GitHub page. So some prerequisites in order to get this up and running. So our Android app is constructed within Gradle and Android Studio. So I'm using the latest Android Studio that's available today. Right now that's 0.8.14. For the server side, we're using Node.js, and right now the version of that is 0.10.33. You also obviously need some EC2 instances running in Amazon, so an Amazon account with EC2 instances. You'll also need AWS IAM access, which is the identity access management area, because we're going to create a user within the IAM framework, and that user will be associated with the mobile app, so that at some point, if you wish to disable it, or if the keys get compromised in some way, you can just delete that user, and basically access is denied from then on. We also need a Google account. This is because we need to be able to set up push notifications. So any Gmail account, which is what I'll be using here, will be fine for that. Okay, the first thing we're going to do is get the source code from Wingman from GitHub. So we're going to go to the Golgi developer account on GitHub, which is Golgi devs, capital G, capital D. And you'll see a list of our popular repositories there. That list may or may not contain Wingman. It does in this case, but in case it doesn't, if you click on the repositories tab, you get to see all our repositories, and then select Wingman, and there's there's our project with all our source. Android, the Android code is there, the server-side code, and iOS. Today we're just going to be looking at server-side code and Android, but we'll download it all. So I'm going to clone it on the command line from GitHub. if you don't want to do that, you can also just download a zip file and zip that. So, but I'm going to use the command line clone. So I take a copy of the URL here. I go to my command line. I make a directory where I'm going to have as my work area. So we'll call it wingman WA. CD in there, and then git clone the URL from the page. We'll pull everything in there. So EC2 wingman, and we have the Android code, the server-side code, and the iOS code. And we'll get back to this a little later. There's some other prep work we need to do before we can actually go build and run it. So we'll move on to the next bit. Okay, so the next thing we need to do is register for a developer account on the Golgi developer portal. So we go to devs.golgi.io and we click on the register button, put in some personal details, name, email address, pick a password, confirm it, and register. And it'll send us an email just to close that loop and make sure we're using a valid email address. So if I go to my inbox, start refreshing, in a moment or two, I should end up with an email. Okay, so here's my email that just arrived. And I click on this link. So this is just to validate that the email address that I used is an address I have access to. And it asks me to, drops me straight into the login page where I use my password. Sign in. I have to agree to the terms and conditions. And there. It just remains for us to download the SDK and install it. So we select that from the download section here. Once it's all downloaded, double click on it. Run install. Say OK to open it. And once installed, it says we're successful. So that's as far as we need to go just at the moment. So the next thing we're going to do is create a Google project that will enable us to use push for this application. So we're signed into Google with our Google account. We need to go to the Google Developers Console and click Create Project. We're going to call this project Wingman, and we're going to stick with the generated project ID. It'll take somewhere in the region of 10 to 20 seconds for Google to create this and populate it wherever it needs to populate it. And when it's done, it should cycle around and drop us into it. So there we go. So now we're in. If we go back to just the project overview, see we have a new project there, which is our Wingman project. So in we go. We need to enable Google Cloud Messaging on that, Google Cloud Messaging for Android. So we go into APIs North, APIs, scroll down to Google Cloud Messaging for Android, turn it on. That should appear at the top here now. It's being turned on. It is. The next thing we need to do is create two keys, one for the server, which is going to be based within the Golgi infrastructure, to send the push notifications on behalf of your server-side code, and another key to allow the Google infrastructure to identify the Wingman application. So the first thing we do is create the server key. We leave this blank because there's no guarantee what IP address we will get from our servers will have in the Golgi infrastructure. So we just create it. And we also create an Android key, which is going to be used to identify the mobile app when it registers. Now, in order to do this, we need the fingerprint of the key store that's used to sign the application. And in kind of normal day-to-day development, that key store is the debug key store in the home directory in the .android directory in the home directory, and that's used by the SDK by default, the Android SDK by default to do signing. So we're going to use this command here, but on the debug key store to get our fingerprint. So I have it ready to go here. There's no password on that, and there's the SHA1 fingerprint that we're interested in. So we copy it out, put it in here, and then add the package name of the Wingman application, io.golgi.wingman, and we say create. So now we have our two keys, and we're ready to proceed on to the next bit, which is where we're going to create the application in the Golgi portal. To create the application in the developer portal, we log into the developer portal using the account we created earlier, and we select from the main landing page here, we select add application. So every application in Golgi has to have an entry in here. It's how we identify them. So it's a new application, just gets created with some default names and stuff, and we'll just edit that a little bit to make it more usable. We also have to add the push credentials. So we're going to call the application Wingman. And in order for push notifications to work on Android, we need to populate a project number and the server API key. So if we switch back to the Google Developers Console, when we created these two keys, the server key that we're going to use is this API key here in the server record. So we copy that out, switch back in the server API key, and the project number we're going to use, if we go back to the developer console, if we just go back to the Wingman application, just select the Wingman application again. On the overview, the project number is specified up here. So we select that, copy it, go to the developer portal, provision that, and save. So once that's saved, our application is provisioned on the Golgi portal called Wingman. It's got an application key which we'll use soon, and the push for Android is all set up. We have our project number and our API key that we just created. So we're done with the record right now. We can go back to the dashboard, and there's our Wingman application with its API key. So that's as far as we need to go at this point here. Now that we've provisioned our application on the Golgi developer portal, we need to copy some of the information, two pieces of information, into the source tree for Wingman so that we can build around it. Every application, every Golgi application needs to have these in there somewhere. The piece of information what I'm talking about are the developer key, which is unique to my developer account, and the application key, which is unique to the application. And in the Wingman source tree, these are expected to be in flat files in the top level directory. So we'll take a copy of the developer key, which is just this long string here, go to our command line. We're in the Wingman directory here, beside the Android server and iOS directories, and we put that string into a file called .dev key, which is the developer's key, like that. And similarly, the application key goes into a file called golgi.appkey, like that. So if we look here, we've got two new files in here, golgi.devkey, golgi.appkey, and they contain the keys that we got from the portal. As part of the prerequisites for Wingman to run, we mentioned at the top that we need to have Node.js installed. We need this because the server side of Wingman, the server component, runs in Node. We also need to install the AWS SDK, because this is what we use to interrogate Amazon to find out the state of to discover the EC2 instances and to interrogate their state. So in order to do that, we need to go into the server directory in the Wingman source code. And as I mentioned about, we have Node installed. If we do node-v, we're looking, the latest as of right now is 0.10.33. That's what we're running here. and we need to install the AWS SDK, which is fairly straightforward. We do npm install AWS SDK, and that should go and get that for us. So if we in here in the node modules, you'll see the AWS SDK is there and ready to go. For the AWS SDK to be able to access your Amazon data, it needs some credentials. So the approach we recommend is you create a new user in Amazon, create credentials, get the credentials for them, and use those specifically just for the Wingman application. Those credentials, how to create them is well defined in the SDK documentation. There are several ways of doing it. The way we're going to use is this creating credentials from the shared credentials file in /aws credentials, and we're going to create a file that looks a bit like, well, almost exactly like this, with the access key and the secret access key that gets generated for us by Amazon. So in the identity and access management console on Amazon, you can create a new user, which we're going to do for Wingman. Now, I've skipped a couple of steps here because it exposes some of our internal info, but you get to a point when you create a new user that you need to enter the user's name. So we're going to say Wingman. We create the user, and we can look at the security credentials. This is our only chance to look at or download the security credentials for this new user. So we've got an access key and a secret access key ID and a secret access key, and we're going to use those in the credentials file. Now, I'm ready to go here with my credentials file all set. I need the access key ID and the secret access key. So I'll copy those across. So there's my access key ID. And get ready for our secret access key. And I save that file. So if we now that file .aws/credentials, you can see there's our access key ID and our secret access key as created by Amazon moments ago. In the Amazon identity and access management console, you then need to go on and assign a role to this Wingman that allows them to interrogate your infrastructure. I'm not going to show that here, so that's kind of an exercise for the viewer. Okay, so now that our AWS SDK is installed, our Amazon credentials are valid and provisioned, we can build and run the server side of Wingman, which is the bit that interrogates and keeps an eye on our EC2 instances. So I'm currently in the Wingman work area here. I go into the server directory. This is pretty much as we left it. I run make, and that builds Wingman service.js, which is the generated code for everything we need to do, plus the actual kind of business logic, if you will, in code.js. And that all goes into this runtime file here, which we should just be able to run like this in Node. It will start up, registers with the Golgi infrastructure, then connects to Amazon and interrogates where all the instances are, and there we go. It's now monitoring all those instances that are currently running that's actually the Golgi test infrastructure in Amazon. Now we're in a position to run the mobile application and view the fruits of our labor, as it were. The server-side infrastructure server-side application is running. It's interrogating Amazon and keeping track of all our instances. So I've fired up Android Studio here. I've selected Open Project, and I select our Wingman work area, EC2 Wingman, go down the Android tree, and select the Wingman directory, and go choose. So that'll start to load up. While that's busy doing that, I will launch an emulator as soon as the menu becomes available, because that's what we're going to run the application on, so that we can see it here in the video. So I launch that in the background. Okay, so back here in our project, the emulator is starting up. Our project here is a standard kind of grade the new look layout. And the emulator is booting up here in the background. It'll take a minute or so to get to the point where we can actually install on it. So we'll just wait for it to get to that point, and then we'll run the application. Okay, so our emulator is up and running now, ready to install, ready to run our application. So we'll just take it out of, unlock the lock screen, back to our application here, and we should be just ready to hit run. It should detect the emulator and ask us once it's built, and ask us to do we want to run on it, which we will say yes. Select that. Okay. And then in the emulator, it will install it and fire it up. So this will take several tens of seconds because the emulator is still actually going through its boot up process in the background. Okay, it starts up, queries the server and gets back the current list of EC2 instances and their CPU usages, and sorts them by CPU usage. So there they all are. That's kind of it in a nutshell. We can narrow this list down if we're interested in just a particular type of instance. We can filter based on the name. So we have some test caches running here. So we can run CACHE, and that will show us, that will display just the caches in the various regions that are running right now and the associated CPU usage. On a per instance basis, we can also, if I clear this out, we can disable notifications. So for example, this always runs at this speed, so we'll suppress orange and red notifications. That little tag there says that there's an instance filter on that. And on the overall, we can decide what we want to get notifications about. If we only want to get notifications about things that we have in the current filter, and so on and so forth. So it's quite a handy little tool for anybody running EC2 instances to carry around in your pocket, letting you know if you need to go and check on some unexpected activity. And that's it. Thanks very much for watching. I hope you found it interesting.